like I need to label a point of a graph. So this is kind of more straightforward. I like these ones, but they are good for building an understanding of what's going on here. So this says Josie throws a stone off a bridge into a river. The function f models the stone's height in meters above the water as a function of time in seconds. Plot the point on the graph f that corresponds to the height above the water from which Josie threw the stone. So I like this question. So the graph here is showing that Josie is standing up on a bridge. She's standing up at a height, and she's going to throw a stone, and maybe it's going to go up in the air at first, but then eventually gravity is going to take its toll, and it'll start falling down. So Josie was holding the rock at when the time was 0 seconds, when this kind of story began, in a sense. So if I'm looking at this function, anything to the left of 0 seconds is not even part of the story. It really shouldn't even be included in the graph. The graph should actually start right here at this point here, because this is when the time starts in our story. When the time is 0, the height is 25 meters. So she is throwing from a bridge that's 25 meters tall. I don't know how strong she is, but apparently she can throw 20 meters in the air, which seems really high to me. Maybe she's an athlete. So apparently she throws it 20 meters higher. It peaks at a height of 45 meters, which is very, very high. And then that goes down, down, down. And after 5 total seconds, the stone hits the ground. So apparently she's like an Olympic athlete as well. But none of that is as important as answering this question. Plot the point of the graph that corresponds to her height when she threw the stone. So I'm going to put the point right here. This is where the story began. She was at 25 meters in the air when she threw the stone. Okay. Oh, fun, fun, fun. It says the function g is given in 3 equivalent forms. So, and it asks which form most quickly reveals the vertex. Well, the vertex can be very easily seen in what's called vertex form. So if you're comfortable with the different forms, there's standard form. That is well represented by answer B. Answer B is in standard form. Another classic form, another standard form, another another classic way to, or typical way to write quadratic functions is in vertex form. This is shown in answer A. It's called vertex form, and it's called that because it's very easy to see the vertex. It's always the opposite of what you see in the parentheses. So that's the x value is 8. It's not -8, it's +8. And then it's the number you see at the end is -8. So the vertex is very clearly seen in vertex form. C is in a factored form, which lets you see the solutions really easily. You can see the two solutions are 12 and 4. Yeah, and A is called standard form, and it's very easy to see the vertex in this form. I believe I wrote it earlier in the video, but you could look into standard form more so, but A is in standard form. The vertex is going to be 8, -8. All right. So we have a quadratic function, and the first question, it says, what are the zeros of the function? Right, the small one first, larger one second. Okay, so luckily this function is written in factored form. We just saw a quadratic in factored form, and it was easy. I just kind of pointed out the solutions. This is one of the factors, r minus 12. So what number could I plug in for r that will make this whole function 0? One of the numbers is 12, because if you have 12 minus 12, that's going to give us a factor of 0. Anything that we multiply by 0 is still going to be 0. So one of the zeros of the function is 12, and the other one is whatever would make this factor equal 0. So I would need to plug in the number -3 in order to make this factor 0. So my other answer is -3. It asks us to put in the two solutions. The smaller one is -3, the bigger one is 12. And now what it asks is, what is the vertex of the parabola? So this parabola, if I'm looking at the function here, I have a positive r and a positive r, but my negative sign in front is going to give me a -r². So I know the function is going to be downward facing, and I know the solutions are -3 and +12. So maybe I would have a graph that sort of looks like this, where -3 is a solution, but so is +12. It's asking what's the vertex. So I now need to find this point up here. I know it's going to be halfway in between -3 and 12, so that's where I'll start. So that distance is 15. Half of 15 is 7.5. So I'm going to go from -3, I'm going to go 7.5. So 1, 2, 3 is going to take me to 0. And then I need to go 4.5 more. 1, 2, 3, 4.5. I know it's like not trying to scale, but x should be 4.5, 4.5. And it's, do I want 4.5? Yeah, you know what? Honestly, I'm gonna use a calculator here, I think. 4.5. So I'm gonna put in 4.5 and the y value. So I'm gonna use my calculator here. So it's going to be negative. And then I have x minus 12, x plus 3. I say x even though it's r. So x minus 12, x plus 3. So it's going to be 4.5 minus 12 times 4.5 plus 3. So all of that together, this will give me my answer and be correct. Yes, it likes it. So there you go. I found the solutions. Halfway in between that is where the vertex will be. And if you know the x value of the vertex, you can plug it in, and that will give you the y value. All right, so this one has two functions. I have f of x is x squared, and g of x is x plus 4 squared minus 1. So if I'm going from f of x to g of x, what I notice is that f of x it's sort of a bland like parent function. There's nothing going on to it. It's just y equals x squared. G of x, there's kind of some fancy stuff going on. So instead of just x squared, I have x plus 4 squared, and then I have a minus 1 at the end. And this is in vertex form, which we've kind of been seeing a couple times, but I'll write it down just for the sake of it. So vertex form, y equals a times x minus h, h squared plus k. So if we're thinking about vertex form, k at the end here is kind of the easiest one to think about. It's a vertical translation. K is a vertical translation. It's just shifting the graph up or down. So for us, g of x, I have a -1. So it makes sense that we're going down by 1. So part of the translation is that we're going down by 1 units. The other part of the translation, or the shift in the graph, happens in the parentheses. And the way I like to think of it, and the way I always teach it, is that whatever you see in the parentheses, it's the opposite of that. So when you see the +4 and you think 4 to the right, it's the opposite. So it's 4 to the left. So whatever's in the parentheses, it's kind of the opposite direction of what you think, because typically right is positive, left is negative, but this one flips that. So for this, we're going to move not to the right 4, but to the left 4. Left by 4 units. That's all I need to think about. Is it's in vertex form. I see x plus 4 in the parentheses, so I'm going to go left 4, and then I see a -1 at the end. I'm going down 1. All right, cool. So this is a quadratic function, and it asks for the value of the discriminant of f. So what I'm going to do, so this I hope is going to work either way we do it. I don't like having the negative 4 in front. So what I always sort of do is I always pull the negative out. For this, I'm going to leave it, and hopefully it all works just fine. I think it should all work just fine. So what I'm going to do is start by writing the quadratic function. So the quadratic function is -b plus or minus the square root of b squared minus 4ac. And that's all over 2a. So this is the quadratic function, and the discriminant is the part of the quadratic function that is under the square root sign. So b squared minus 4ac is known as the discriminant. So it wants us to find the value of that. So let's take our numbers. So b is 12. So if I take b squared, that's 144. And then I'm going to subtract 4 times a times c. So 4 is 4. A is -4. C is -9. So we're going to be left with 144 minus, and this is going to end up positive. So it's going to be 4 times 4 is 16. So 16 times 9, or it's going to be 36 times 4. I don't want to do that in my head right now. So let's do it in the calculator. So let's do oopsies. So 4 times 4 times 9, just to make sure it's right. 4 times 9. That would all come out positive. We're going to subtract it. Oh, interesting. So it's going to be 144 minus 144. So our discriminant is 0. Wow. Wowie wow. So minus 144. I'll finish it out. Remember, it's minus, and this was two negatives, so it's positive. So it's 144 minus 144 equals 0. So the discriminant tells you how many solutions you have. So the quadratic formula will tell you your two solutions. And what the quadratic formula does is it has this plus or minus. That's how you get two answers. So when you plus or minus a number, you're going to get two different numbers. Hopefully that makes sense. If you add or subtract some number, you'll get two different numbers. The weird thing, though, is that we're taking the square root of b squared minus 4ac. So if we take the square root of a number, the number 0, for example, there's only one square root of 0. It is 0. So when the discriminant is 0, when the number under the square root is 0, we actually only have one solution, because if you add or subtract 0, you get the same number. It doesn't matter. If the discriminant is positive, you're going to get two solutions because you're adding and subtracting a number. It only gets weird when it's negative because, and let me erase just to remind you, if you take the square root of a negative, that does not work. You can't take the square root of a negative number. So when the discriminant is negative, there are no real solutions. There are only imaginary solutions. When the discriminant is positive, there are two solutions. When the discriminant is 0, there's one solution. So this is like the rare, strange case where the discriminant is 0, and that means there's one solution. So this says Rui is a professional deep water freediver. His altitude in meters relative to sea level, x seconds after diving, is modeled by d of x is 1/2 x squared minus 10x. Okay, and it says what is the lowest altitude? What is the lowest altitude Rui will reach? All right, so let's do the graph thing again. Let's say there is water. This is the sea level, and it's a diver that I think is probably starting at sea level, and then we'll go down and back up. And I'm assuming this shape because I see it's a quadratic equation. So it's going to be a parabola. It's going to be a U shape. And I see this is a positive 1/2. So it's going to be an upward facing U shape. So the diver at some point will bottom out. And that's what it's asking. What's the lowest altitude Rui will reach relative to sea level? Okay, so where is this going to be? So what I'm going to do is I'm going to figure out where does the diver start and where does the diver come back. And x is measured in seconds. So this is actually, I drew it like this, but it's a graph. And x is the amount of seconds that passes. So I want to figure out where he starts is probably 0, and where he ends, we're going to figure that out. With this function here, what I can do is I can pull out, I'm going to pull out 1/2 x. Kind of weird. It'll be left with x minus, and then this should be 20. So I pulled out 1/2 x. If I multiplied it back, I would get the same thing, 1/2 x squared, and then 1/2 of x minus 20 is minus 10x. So what this does is it lets me see the solutions to my equation. So what numbers could I plug in to make the height 0? Remember, this is d of x. What x's could I plug in to make the function equal 0? That means I'm at sea level. One of them is 20, so I could plug in x as 20, or I could have x as 0. So my two solutions here, or when the diver starts, is at 0 seconds, and when the diver comes back is at 20 seconds. That lets me know that the minimum point is halfway in between that at 10 seconds. So at whenever 10 seconds has passed, that's going to be the minimum point. So I know x is 10, but I don't know the altitude. I don't know the how low the diver is, but I can plug in 10 for x. So it's going to be 1/2 of x squared. So that's half of 100. 10 squared is 100. Half of that is 50. So it's going to be 50 minus 10 times 10. So it's going to be 50 minus 100, which is negative 50. So the diver, I think, should be 50 meters below sea level. Negative 50 is the altitude relative to sea level, I believe.